Finally, I want to talk a bit about the positives and negatives of using stepwise and best subsets regression. First, as a reminder, these methods are for predicting. You want to predict the outcome. They are very bad for models that want to understand the relationships in the population. So, first with the positives. It may help identify important variables that you could have ignored otherwise. It helped sifting through a large number of variables to build a predictive models. And so when you do that, you might identify good variables that you could have ignored just based on your intuition. Now, on the negatives, it won't tell us when we have a borderline case when one variable could be included but didn't make it. It won't account for potential transforms or interaction unless you specifically create the logs and so the log of a variable, the square and other transforms. It's the same for the interactions. Unless you specifically create the interaction, it won't try the interaction in the various models. It won't tell you why some variable matters and some not. It will just blindly follow a criterion to include the variable. It won't provide information on theoretically important variables that turn out to be less impactful. Let's say, for instance, that you're trying to predict sales and there is not enough variation in price, even though it's supposed to be very important. It might include other variables, but exclude price from the model. However, in theory, if you change the price a lot, it will affect the sales a lot, but maybe just in our dataset, we didn't have a lot of variations in price. So it was not relevant for this sample. Then different approaches may produce different best models. Also, it depends on the criterion you pick, whether you pick p-value, adjusted R-square, CP statistic, the BIC, Bayesian information criterion. So each time you might have different best models and you'll have to pick one, but you won't necessarily know why you want to pick that one. And finally, it might capitalize on sample randomness when it selects the parameters. So that's subject to overfitting. Basically, we're using in-sample statistics, adjusted R-square, p-value, BIC, CP statistics, they are all in-sample. So if it happens that some variables are a bit too informative for this sample, but that was just a product of chance, they might be included, whereas they shouldn't necessarily be included. And we'll see later that we can use out-of-sample statistics instead to try to avoid these kind of issues.